Welcome back to Miss Lisa's Math and Science. Today we're in physics and we are going to do some math that has to do with chapter 5 in physics, which is going to talk about forces and motion and things like that. It's forces, but we'll be talking about different problems with forces. Now, so like, share, subscribe. And I'm doing this way where it's two, where you can really see what's going on with the math and with the calculator up close. So instead of seeing me, you're going to see my calculator. If you want to see me, go back and watch the other video. So our first problem is on page 91. You can read it out of your book, and I will read it out loud. If you are not doing this class and you just want to see the math, that's fine too. Welcome. We accept all here. All right, so our problem is, what net force is required to accelerate a 1,500 kilogram race car at positive 3 meters per second squared? So what you do when you read a word problem is you get rid of everything, all the words, and just get it down to numbers. So what we're trying to find out is the force. Our mass, they told us, was 1,500 kilograms, and the acceleration is 3. So, and then the other thing you might need to know is 1 kilogram meter is a Newton. All right. So what we do once we write down our knowns and also our unknown, right? What they're asking for with a question mark. I can't tell you how many times I've solved a problem correctly, but I did not solve the problem they asked. I got something else, something else also nice, but not what they asked for. But if you mark your knowns and unknowns, you're going to be more likely to solve the right problem. Okay, so now you think, is there a formula that relates force, mass, and acceleration? Yes, there is. The famous formula, F equals ma. So step 2 is you write down your formula. Now write it down every single time. It's going to help you memorize your formula, and it also helps you show your work. So we want to show our work so we get full credit. A lot of professors and a lot of teachers, not just me, take off more for a wrong answer than for I said that wrong. We take off more for a blank than a wrong answer. I can give you part credit if you give me something to work with, but if you just leave it blank, you're getting it all wrong. So always guess, always show your work. Don't do it in your head, because I'll take off half also if you don't show me your work, because I don't know that you didn't cheat, that you didn't peek over at someone else's paper. I need to see that work. Okay, so step 1 of having your work is write down your formula, then we sing a song. The song goes like this. Substitute. It's from The Who. It's before my time and yours. But we sing it to help us remember that we substitute. And how we substitute is underneath the letter, we write what it equals. So mass is 1,500. We write that down. Under acceleration is 3, we write that down, then we do the math. So on our calculator, we'd come over here. This is the regular math screen on your TI-84, and we just put in 1,500 times 3. Now, some of you could do that in your head. I want you to get in the habit of, whenever possible, do it on your calculator anyway, because your calculator doesn't get nervous. Your brain, your calculator might have a brain freeze and not do it right. But if you miss a problem, I want it to be because you didn't understand the physics problem, not because you did a dumb math mistake. So get in the habit of using that calculator. You paid a lot for it, use it. Okay, so the answer is 4,500 and the unit is newtons. All right, let's do number 2. So these are our unknowns and unknowns. You read along with me. If you've got the book, it's on page 91. An artillery shell has a mass of 55 kilograms. So I don't care that it's a shell. I'm going to write mass 55 kilograms. I just want to get it down to numbers. The shell is fired from a gun, leaving the barrel with a velocity of 770 meters per second. So that's my final velocity. My bullet started at 0, so I'm going to write that down too. The gun barrel is 1.5 meters long. That's a distance. I wrote that down too. Assume that the force and thus the acceleration of the shell is constant while the shell is in the gun barrel. What is the force on the shell while it's in the gun barrel? Force equals, I don't know. So I think about, is there any formulas? Well, there's F equals ma. And then they also are going to ask the acceleration. So to be able to do F equals ma, I need acceleration. So I'm going to use this formula. The final velocity squared equals the initial velocity squared plus 2 times acceleration times distance. I've got all of that but the acceleration. Now, the book rearranged it for acceleration. I tend not to. I'll go ahead and substitute it in here and solve it here. But just for time's sake, and sometimes it makes me do harder math, and I don't mind doing harder math. I like math, but just for simplicity's sake, and since it's what's in your book, we're going to use where they rearrange the formula for acceleration. Now we're going to sing substitute and put in for final velocity 770 squared minus initial velocity 0 squared, which, you don't really have to, but makes the work nice, times 2 times the distance. Put it all in our calculator. Now, when we put that in our calculator, I'm going to do 770, and I'm going to use this button right here for squared. See that button? And now I do divided by, I need to put this in parentheses. My calculator has a hard time knowing exactly what is being divided here. So I do 2 times 1.5 in parentheses. I always tell my students, you won't regret using too many parentheses, but you will often get it wrong because you didn't use enough. So there's the answer. Now, the proper thing to do is to keep the whole thing to the end. Your book doesn't. They're not really following the rules. So they rounded it off. What you would normally do is now we're going to use F equals ma. And the mass is 55, and that's the acceleration. While I have this in my calculator, so I don't want to rewrite it, I can just do times, and it says answer times 55. And there is the answer, and that's in newtons, but your book rounds it off to 1.1 times 10 to the 7th newtons. If you had this, I would count it right. They're considering significant figures, but they're not really using the rule for significant figures because they rounded it early. So it just depends on the teacher you have. If you have a different teacher than me, you might need to do it like that. Your teacher might take the other one. All right, let's go on to number 3. Number 3 is on page 99 in your book. So I'm going to turn over there. You can hear my pages turning. There we go. Okay, so this is our problem here. It is one about the formula that weight equals mass times gravity, but we don't know that yet, but we will. I'll read it out loud. It says, a smooth wooden block, I skipped it. I'm on number 4. I'm like, that's not that. That's a friction problem. Okay, here we go. It's on page 94. I can't read my own handwriting. All right, find the weight. So you put weight question mark of a 2.26 kilogram. So mass is 2.26 kilogram bag of sugar. Well, is there a relationship between weight and mass? Yes. You multiply mass times gravity to get weight, and the acceleration due to gravity is 9.8 meters per second squared. So we write our formula. We sing substitute. We put in 2.26 times 9.8. And on our calculator, so I'll get my calculator here and do it for you, 2.26 times 9.8 equals 22.148, and your book rounds that off to 22.1 newtons. All right, now we can do number 4 on page 99. I was getting too excited. All right, so we're going to read the problem and write down our knowns and unknowns. It says, a smooth wooden block is placed on a smooth wooden tabletop. Now, for this problem, it doesn't matter what these are. I used to teach a physics class where we would have to look up mu by what the surface is, and those would matter, but for this one, it doesn't. You find out that you must exert a force of 14 newtons to keep, so my force is 14 newtons, to keep the 40 Newton block moving along at constant velocity. So my weight is 40 newtons, okay? what is the coefficient of sliding friction for the block and table? So what they want is mu. The acceleration here is 0 because they said it was constant speed. So what's our formula? It's fun. See, it looks like fun. I told you that in the other video. It's force equals mu times the normal force. The normal force is the same as the weight. They're equal and opposite. So, and mu is what I'm solving for. My force is 14. Why is mu not alone? See, it's always fun when you're getting to use Greek letters. It's because it's being multiplied by 40. So what's the opposite of multiplying by 40? Divide by 40. What you do to one side, you do to the other. That's how you get things alone in algebra. You just do the opposite because you're allowed to do anything you want as long as you do it to both sides. Those 40s cancel out. 14 divided by 40 is 0.35 mu. It has no units. Those were both newtons and they cancel out. This is a constant. Constants don't have units a lot of times. Okay? The second part of the problem says, what if you put a 20 Newton block on top? Well, now our normal force is the two weights added together. 20 plus 40 is 60. We use our formula again. Friction is fun. F equals UN. Mu we solved here is 0.35. Our force, our normal force is 60. 0.35 times 60 is 21. And the unit of a normal force or a weight is newtons. So it's 21 newtons. So that one was fun. I like all these problems. There's some problems, I'll just be honest with you, that I don't like as much in physics, but I think these are all fun. Not just because it says fun. All right. Our last problem is number 5. It's on page 101, and I will read it to you. It says, a spring scale hangs from the ceiling of an elevator. That's weird. I've never seen that in real life. It supports a package that weighs 25 newtons. Okay, so we got a spring scale holding a package. And so our first thing we have for our facts here, let me draw a line between, we're going up here. Our weight is 25 newtons down. We're going to not have any acceleration to start with. It's just sitting there. It hasn't started. So the forces are all balanced. Everything's sitting there. So the force is 0 to start off with. What is the upward force does the scale exert when the elevator is not moving? Okay, well, if it's not moving, that means the weight is the same as the force, the normal force. It's 20, so all forces are balanced. So the spring scale is, the weight is pulling down 25 newtons. The spring scale is pulling up 25 newtons because the forces are balanced. Okay, part B. What force must the spring scale exert when the elevator and object accelerate? So now our elevator started and it's going up 1.5 meters per second squared. Okay, so we want to know, we can use F equals ma, but we need to know what the mass is. So to get the mass, we're going to use our formula, weight equals mass times gravity. We're going to sing substitute and put in gravity 9.8 and weight 25. Why is mass not alone? It's being multiplied by 9.8. So we did the opposite. We divide both sides by 9.8. These cancel out, and the mass is 2.55 kilograms. Now, the book rounded off to 2.6, but I tell you, you're not really supposed to do that to the very end. But we'll just go with the book. Okay, so now we can use it. We can sing substitute, and we can put in 2.6 for the mass, 1.5 for the weight, and the force is 3.9 newtons up on the scale. But then they wanted to know the net force, so that would be the scale plus the weight. The scale is 3.9, we just solved for that, and the weight is 25 newtons. You add them together, and the total force, the net force is 29 newtons up. All right, and so do that on your calculator. It's fun, it's easy. Pause the video, make sure you can get it. Math and science are great. Come back next time and we'll learn something else.